Everyone, welcome to the P1 Classical Mechanics lecture series. So, in this lecture, which is called P108.9, so in this lecture, I'm going to do another problem of application of the Newton's laws. So, we are going to do a simple problem which is much more insightful and maybe much more beneficial for you. So in this problem, I'm going to introduce the problem right away. So the problem is like this. So what you have here is a wedge, right? So a wedge is like that. A wedge is a small piece of wood or metal or anything like that, which has a shape like this. Okay, this is a solid piece of wedge. So I'm going to call this W, wedge, right? And there is a box, right? There is a box on the surface of the wedge, right? Like this. Okay, that's the box. So this is the box, and this box is sitting on there. Now what I'm going to do is that I'm going to push this box with some velocity, right, with some acceleration. I'm going to push this box here. So I'm going to give some acceleration a to this wedge, right? So if the wedge is pushed, right, then this box is going to move, right? The box is about to move, and this box will have some acceleration of its own. So what will be the acceleration of the box? The acceleration of the box will be some kind of a vector, say acceleration of the box. Okay, so some kind of a vector, so it will have x component and y component, right? So a x of box and a y of box, so two components will be there. So I want to find out what the acceleration of the box is, right? And the most important thing is that I'm ignoring the friction of the surface of this wedge. So the friction is approximately equal to 0. It's almost negligible. Okay, so we are not considering the friction. That's the only thing. We are not taking part in this problem. So I need to find out what the x component is, what the y component of the acceleration of this box, right? This box is free to move around. So what will be the acceleration? So let's also assume that this angle is some 45 degrees, right? Okay, this angle is 45 degrees. That's the whole information that we have. Okay, now to solve this problem, what I can do now is that I know to all the information I have is the acceleration I'm giving, and then the what the angle, which is 45 degrees, and that's all. Maybe the dimensions of this length and the dimensions of the distance and all that, right? So what I can do now is that I can make sense out of these numbers, this information. So for that, I'm going to redraw this same thing, the same wedge, just like that. I'm going to redraw with some 45 degrees. This is no, this doesn't look 45, but it is 45 degrees. And then there is this box, right? So I'm going to make some assumptions that initially the box was here, right? And then when I give the acceleration, the box shifted to this new position. Okay, and also the box has shifted, right? The box has also shifted. So the distance of the wedge, the from the initial point, is some xw, the distance traveled by the wedge, and the distance traveled by the box, right, box is some xb. Okay, the distance traveled by the box is some xb, and the height of the box, right, the height of the box is some y of the box b. Okay, and the length of the dimension of the box is l, the base length. Okay, this is all I can assume. Now why did I took these things, right? There is a reason for it, because I need to connect these 45 degrees with the rest of these dimensions, right? Yb and l and xw and all that, right? So I can incorporate them into some kind of an equation. Well, I have a very basic equation for that. The equation I can use is trigonometry, right? It's trigonometrical equation. So what I can do is that I can find out tan theta, right? Maybe tan or cos or anything. Let's find out tan theta. So tan theta will be, this theta is here, so it looks just like this, some 45 degrees, and this is yb, right, from this picture itself, and this is some distance, I don't know, I'm going to call this distance k, I don't know what the distance is, right? So tan theta will be yb by k, right? Okay, so that's something I can use. So what is k? So I need to know k for that. Okay, so I have to measure k. So how can you connect k with the rest of these things, right? So for that I can use a simple principle, simple idea, right? So the distance k, this is k, right, this is k, k will be what? K will be the this distance, the total distance, right, total distance minus the this distance, right, this distance up to here. Okay, so k will be the total yellow line minus the blue line, the hard blue line. Okay, so that will be k. So what is the yellow line? Yellow line, the total distance. The total distance can be written down as maybe I'm going to remove that. Okay, total distance can be written down as, it will be xw, right, xw plus l, right, xw plus l will be the total distance. Okay, and the this distance, the rest of this distance, what will be this distance, the blue line distance, what will be this distance? This distance will be, can be easily written as, so this minus k will be equal to this minus this distance. What is that distance? That distance can be written down as xw, right? Let's see, xb minus x w, I guess. So it can be divided into two parts, right? So the two parts are this part and the second part, which is this part, right? So this part, the first part, yellow part, will be minus xw plus the second part will be the whole xb minus xw. So xb is this length, right? So xb is this total length minus xw will be the rest of this part, so that will be this part. So it will be xb minus xw, so that is equal to k. So we have found out k. Now let's simplify this. Okay, we don't want this much complicated thing, so it will be xw plus l minus xw minus xb plus xw, right? Okay, so you have one xw was cancelled, right? Sorry, xw was cancelled, this remains, so xb remains, right? Xb remains, xw1 and xw cancel, so you get l minus xb plus xw, so that will be the remaining, so that will be equal to k. Okay, so you found out k. So L minus xb plus xw is k. Now substitute that back into this equation, right? So you get tan theta is equal to yb by L minus xb plus xw. So that's tan theta, right? So tan theta is 45 degrees, right? So this is equal to tan theta, tan 45 degrees. Tan 45 degrees is equal to 1. So you find out that yb must be equal to L minus xb plus xw. So very simple. So we have connected them all together. Okay, so we found out yb. Now why I did that is that I need to find out the acceleration, right? So the acceleration of the this box is my interested component. So we have the distance here, right? So distance is there, so you can maybe easily imagine that yb is this distance where the box is, this is yb, and xb is the distance of the box. Okay, so I'm going to take the second derivative of this whole thing, okay, so that it can be transformed in terms of acceleration. These are all distances, so let's turn them into acceleration. So you get d square yb by dt square must be equal to d square l by dt square minus d square xb by dt square plus d square xw by dt square. Okay, so we got all that. So d square yb by dt square, what is d square yb by dt square? So yb is this height, right? So the height of the box. Okay, let's draw them in terms of symbol representations, that's easier. So yb is the height of the box. Use another color. Okay, yb is the height of the box. This is the yb, this is the box, this is yb. And L is the length of the wedge, right? So L is the length of the wedge. This is L. And XB is the length of the box. XB is the length of the box from the initial starting point. XW is the length of the wedge after moving, right? So XW. So dyb by dt square is, what is that? It's the change of uh, acceleration. It's the acceleration uh, in the y-axis for the box. So it's the acceleration. So that is actually the component of acceleration in the y-axis, ay for a. So that is ay. So you can just write down that this is equal to, so this will be equal to ay of the box on the right side must be equal to d square L by dt square. So the length of the base of the box is not going to change, right? So the length of the base of the box is not going to change. That means that what the this thing is going to be 0. So that will be 0 minus d square xb by dt square will be the xb, which is the distance traveled by the box in the x-axis, right? So that will be equal to a in the x-axis, this component, right? So it will be a of x of the box, right, plus the xw is the distance traveled by the box. The acceleration xw is the distance traveled by the box, by the wedge, right? So you can say that will be the a of the wedge, right? That will be the acceleration of the wedge. So we found out that ayb, I'm going to write this down. So ayb is equal to minus a of xb plus aw. So aw is what we initially applied, right? The applied acceleration to move the box, move the wedge, was the aw. So aw can be connected with a x component and y component of the acceleration of the box, but we still don't know what the x component and y component of the box is. So that's something that we need to find out. Let's call this equation 1. So we are finally at some place, we know something right now, but this is not enough. We need to find out what yb and xb are. That's the important part. So for that, I'm going to maybe redraw this whole thing. Okay, that was equation 1 for you. Now I'm going to redraw this whole thing and maybe simplify this. You can see that there is this box sitting over here, right? So there is this box sitting over here with some angle theta, right? So there is this normal force, and the gravitational force is attracting it downwards. So it's mg is going downwards. So the normal force, I'm going to use Newton's laws for solving further this problem and get some additional benefit from this, right? So that's the intention. So let's use Newton's laws. So Newton's law, second law, gives you F equal to ma. So I need to find out the force and the acceleration as these components. I have to dissolve this whole structure into this set of equations in the x-axis and as well as in the y-axis, right? So in the both axes, I need to find out the force and acceleration. So if you want to resolve that, you can say that this component, this normal force must have some component in the x-axis and the y-axis, right? So it will be some nx in the x-axis and the ny in the y-axis. Okay, so that's how it's going to resolve, right? So how can you connect them? So for that, I'm going to draw the force diagram, which is something that only has some force in it, right? So if you draw the force diagram, you can see that this normal force, just like that, with some theta angle, this is 45 degrees, right? if it is like that, and then there is, you can resolve it in terms of x and y axis. Okay, maybe redraw because it's not that good. Okay, so let this be the wedge and this be this angle theta, and there is the normal force just like that. Okay, so this is much more better. This is the x axis and this is the y axis. So there will be mg in this direction, so mg is in this direction downwards, and that's an one force. This is the normal force, and this has the x component nx, and this has the y component ny. Okay, so these all components are there. So if this is theta, okay, if that is theta here, so then these are two parallel lines, right? These are two parallel lines, so you can say this will also be theta. Okay, okay, that will also be theta. So this will be 90 minus theta, right? So that will be 90 minus theta, and so this angle will be theta again. Okay, okay, you got that, right? So now you can say that this length is also, and this length the same, which is ny, and this length will be the same, so that is nx. So now I'm going to draw this, only this triangle. Okay, this triangle to the side. So I'm going to draw this triangle, which is looks like this, right? This is theta, and this is ny, and this is n, and this is nx. Okay, I got that now. So now you can write down that you can write down that cos theta will be equal to ny by n, right? And sine theta will be nx by n. Okay, so you can write down that as well. So ny is equal to n cos theta, and nx is equal to n sine theta. Okay, very simple. Okay, now if that's in place, now in the x-axis I have to write down the forces, right? So in the x-axis you can say, in the x-axis you can say that, okay, F is equal to ma. So you look at those forces here. So in the x-axis the forces are nx is there, and that's it. There is no other force, there is no friction or anything like that, we just ignored that. So that's why in the x-axis there is only nx. Okay, the rest is history. So there is only nx, there is no other thing. So in the x-axis the force is equal to ma, so force is equal to nx must be equal to m times a of box in the x-axis, right? That's the acceleration. Okay, and in the y-axis you can now look at the y-axis. So y-axis, if you take the going up as positive and going down as negative and going to the right as positive as well, then mg is in the downwards direction. So there is two forces, which is mg, and there is normal force ny, right? So you can say that mg and ny are the two forces. So if equal to ma, so no forces are n y, and minus mg must be equal to ma box in the y direction, right? So you got that. So now what you can do is that you can simplify this, you can maybe simplify this. And now what I can do is that I know nx and ny, right? Let's substitute those values in here, right? So you get nx is n what n sine theta, right? So n sine theta must be equal to mabx. Okay, so n is equal to what n is equal to mabx by sine theta. Okay, you got that. Now what I can do is that I can substitute here as well. Here in the second equation as well, I can substitute for ny is equal to n cos theta. So substitute that. So it's n cos theta minus mg is equal to maby. So now I can substitute the value of n in this equation, right? So the n is here, so let's substitute the value of n in this equation. So n is equal to mab in the x cap direction cos theta divided by sine theta minus mg is equal to some ma by, right? So what you can now do is that you can simplify this. M is always there, so M will cancel each other in the all sides, and cos theta by sin theta will be cot theta. So you get a bx cot theta minus g is equal to m sorry a by. Okay, so you can write down the cot theta is 45, so cot 45 is also 1. So a in the bx direction, in the bx cap direction for the box, minus g is equal to a in the what, in the by direction. Okay, so you got that very simple stuff from that. Okay, so now what I can do now is that maybe use the. So now what I can do is I can go back to the equation 1. Let's call this equation 2, right? So I got two equations here connecting a by and a bx. So this is equation 2, and go back to equation 1, right? Equation 1, I had a yb is equal to axb minus axb plus aw. So I'm going to substitute a yb back into this equation, the two equations. Now so you get a bx in the x cap direction minus g must be equal to a by will be what, the box in the y cap direction will be what, a minus a b in the x cap direction plus a w the acceleration of the wedge, right? So substituted that 1 in 2. Now what I can simplify, I can simplify this. So you get 2abx is equal to g plus aw, right? Okay, I got that. So abx, I have found out abx, the x component of the acceleration of the box, which is g plus aw by 2. Okay, so I found out that. Now what I can do is that I can substitute this back into the equation of what, say this equation, right? 2. So when I do that, I can find a by as well. So a bx is equal to g plus aw by 2. So a by will be equal to a bx, which is g plus aw by 2 minus g, right? So minus g, so that is minus g. Okay, so you get, okay, I think I get it right. Okay, g by 2 minus g. Okay, a by is equal to, no, a, okay, a by is equal to, now I can simplify this equation and you get a w. So you get g by 2 minus g will be what, minus g by 2. So it will be a by is equal to a w by minus g by 2. Okay, so that's a by, and this is a b. I'm going to call this equation 3 and equation 4. So I found out the x component and y component of the acceleration vector. So acceleration vector for the box is equal to a bx in the x cap direction plus a by in the y cap direction, and I can substitute those values and you get a plus was that, right? A plus, okay, aw plus g by 2 small aw, which is for acceleration for the vector, plus g by 2 the x cap plus aw minus g by 2 in the y cap direction. So that's the vector, acceleration vector. So if you know the acceleration of the, if you push this wedge with the box here and push with acceleration a w, then you know that this will be the acceleration of the box in the x cap and y cap direction, right? So you can find that out easily. So this is a very useful problem. This is a very certain aspect of how you look at problems and how you solve them faster, right? So I hope you benefited from all this, and with this I'm going to close this lecture, and please like and subscribe these videos and our channel, right? for more videos. Keep watching. Okay, thank you guys.